Hi, I'm Juan Loaiza, and today I'm excited to talk about data-driven apps made simple. I'm going to talk about a number of topics today, starting with what it means to be data-driven. So, creating value from data increasingly determines the competitiveness of enterprises. And to become data-driven, enterprises need to take advantage of data-driven apps and paradigms. So let's talk about data-driven apps. So data-driven apps are apps that create value from data in new ways. And there's a lot of new ways to create value. Things like machine learning, real-time analytics, Internet of Things, social graph analysis, documents, text search, spatial processing, and blockchain. Now, these algorithms add tremendous amounts of value that were never possible before. However, they come with complex new products and databases to implement them, and they can fragment data into silos. So this creates much more complexity than we had to deal with in the past. Also, data-driven apps are built using new development paradigms. And by new development paradigms, I mean things like microservices and events and SaaS and distributed data, CI/CD, API-driven development, defense in depth, and low code. Again, new development paradigms greatly simplify development. However, they complicate the data architecture, and they can create more data, which increases management complexity. So what we want to do is make these new kinds of apps much simpler. And we can do this using a number of different techniques. For example, by simplifying the development paradigms using synergistic data paradigms. Also, by providing easy-to-use declarative implementations of the new data uses and types inside the core database. And eliminating the data fragmentation by using a single converged database for all the data types and uses. And by eliminating data management complexity using an autonomous cloud database. Okay, so let's get started talking about creating value faster using these new development paradigms. So as I mentioned, these modern development paradigms are great, except that they complicate the data architecture. And what we are doing is we're coming up with ways to eliminate this extra complexity by pairing each of the development paradigms with a synergistic data paradigm. So what we want is data and dev not fighting each other, but being synergistic, working together. And I'm going to talk about each of these development paradigms and how we make these simpler with a synergistic data paradigm. So let's start with a very popular new development paradigm called microservices. So we can use pluggable databases to greatly simplify microservice architecture. So Oracle makes it simple for each application microservice to store its data in a logically separate data container called a pluggable database. And the advantage of this is that using pluggable databases, we can easily physically combine or separate the logical databases into physical databases. So we can break them apart into separate physical databases, put them together, and this allows us to improve the isolation and scalability. So in the example here, we have the microservices, which are run inside app containers on Kubernetes, and each of the microservices runs using its own logical pluggable database, which then can be combined or separated into separate physical databases. So this helps make microservices much simpler. Okay, next let's talk about event-based architectures, another very popular development paradigm. And in Oracle, we have something called database queues that make it easy to implement events-based applications. So Oracle implements event streaming to and from Kafka. For example, Golden Gate replication can stream database changes into Kafka. And we have a new Oracle database capability that allows you to query events out of Kafka. Also, Oracle database has had something called database queues that have supported events inside the database for many decades. And database queues provide ACID transactions and powerful SQL queries over events that are in the database in queues. And we've now developed a Confluent connector that can stream events between Kafka and database queues, making them work seamlessly together, making events much simpler to develop. Okay, next, let's talk about API-driven architecture. So we have in Oracle something called data as a microservice, which allows data to be accessed as if it was a separate microservice to make API-driven architecture much simpler. And the way this works is that Oracle automatically generates a REST API on top of either SQL or views or stored procedures. So you start with a stored procedure or view, we generate a REST API automatically on top of it. And then the advantage of this is applications can access data like they access any other service by making REST calls. And this simplifies and standardizes the APIs to access data. So it's all just REST. Also, by creating a REST API on top of a Java or PL SQL stored procedure, we can extend application microservices within database functions or lambdas. And these avoid slow network round trips. So this is very much like JavaScript in the browser is used very commonly to avoid network round trips. So again, by using this API-driven architecture, treating data as a microservice, we make API-driven data architectures much simpler. Now let's talk about SaaS architectures. Oracle makes it very simple to implement secure and modular SaaS applications. And we do this by using a separate logical database or PDB, pluggable database, for each SaaS tenant. This makes it dramatically easier to develop because tenants are transparent to the app. And it's more agile because tenants can be easily cloned, moved, etc. The database enforces tenant security when you use it this way. That means that you don't need to write risky code in the application to separate tenants. And this is not just an application, but every module of the application. This also enables tenants to use standard tools like analytics tools because the analytics tool can run directly against the tenant database. It won't see anyone else's data. Now, using pluggable database to implement SaaS apps is already used to implement highly sophisticated SaaS applications like NetSuite, Fusion Apps, and Taleo. So using pluggable databases makes SaaS apps much simpler to develop. Next, let's talk about low-code application development. Low-code apps is a very popular way to rapidly develop apps, and Oracle makes it dramatically simpler to create low-code apps. Oracle has an IDE called Apex, which automatically can create an app starting from a spreadsheet or a table. So it's truly data-driven. But Apex goes well beyond other low-code IDEs because it has very deep integration with the database that eliminates much of the complexity of operating and installing an app. For example, with Apex, you don't have to think or worry at all about middle tiers, connection management, state management, mapping database types to application types, scaling, or high availability. It's all taken care of automatically for you. Also, Apex lets you create enterprise apps in hours, which is the fastest time to value, and you can easily iterate the app to match the evolving needs of the business. Now let's talk about distributed data architectures. Oracle makes it super simple for apps to deliver either data sovereignty or massive scale by using native sharding inside the database. So what a shard is when you break a large monolith database into a farm of smaller databases. And these smaller databases can be placed in country to satisfy sovereignty. So for example, you can have the EU data in an EU shard database inside the EU country. So shards, one advantage of shards is they are fully isolated. And this enables linear scalability of both data and users and processing. And the way native sharding works in Oracle is that SQL is routed to the correct shard based on the shard key. Or if the shard key isn't specified, we run across all the different shards automatically. And one of the key benefits of native sharding is that we allow the online addition and reorganization of shards. When you do sharding by yourself, it's dramatically difficult to do this. Also, we provide all the benefits of a sharded database together with all the benefits of a mature SQL database. So you get you get a mature, fully functional SQL database that has transparent sharding built into it. This makes distributed data architecture dramatically simpler. In a 24/7 world, it's imperative to have continuous delivery of application enhancements. And Oracle makes it simple to do this. There's no need to batch app changes into infrequent downtime windows. And the reason for this is that Oracle supports fully online schema and data evolution. And there's a number of technologies that we have that enable this. For example, we have something called edition-based redefinition that allows you to have multiple versions of a schema running simultaneously. We have something called online table redefinition that allows a table, not just the definition, but the actual data to be changed and redefined while the application stays online. And we natively support data structures like JSON and XML that can be easily changed online. This CI/CD technology in Oracle is extensively used today by many sophisticated applications, for example, Salesforce, eBusiness Suite, and Fusion applications. So using these, Oracle makes CI/CD dramatically simpler. Now let's talk about defense in depth. Oracle makes it simple for apps to secure data in depth. And we do this because we allow end user data privileges to be declaratively defined and enforced within the database. So I'm talking about end users, the actual user of the application. The benefit of this is that it complements and simplifies application level security, and it ensures the same data security is used across all the different app modules. It also adds an extra layer of protection to defend against app security bugs. And the kind of technologies that we're talking about here are real application security, label security, and virtual private database inside the Oracle database. So this makes it dramatically simpler to implement defense in depth. We just talked about how Oracle, by pairing synergistic data paradigms, can make the new development paradigms much simpler. Now, let's go on to a different topic, how we can simplify the creation of value from data in new ways. So let's start with a very popular topic now, which is machine learning. So Oracle makes it very simple for apps to use machine learning to make data-driven predictions. And we do this using declarative SQL to run machine learning directly on business data inside the database. So with Oracle, we built in over 30 in-database parallel machine learning algorithms, including deep learning. These allow real-time recommendations, fraud detection, sentiment analysis, etc., to be easily implemented inside an application. And we can augment our in-database algorithms with Python or R algorithms that you can load yourself. Previously, machine learning was a priced option. Now it's free in all Oracle database editions, so you can easily use it for any app. And using these built-in SQL-based algorithms, we make machine learning dramatically simple. We have lots of machine learning algorithms. You can see on the screen, we have many classification, clustering, time series, anomaly detection, regression, attribute importance, SQL analytics, etc. All these are focused on machine learning for business. Let me show you a quick example of how easy it is to run machine learning inside your database. So here's an example. I'm going to build and train a machine learning model to determine which customers will buy season tickets. So you see this procedure I call here. All I got to do is pass it the table name that I'm building the model on, the name of the model, and the algorithm I'm going to use. Once I've done that to build the model, I can run predictions. So for example, I can call this prediction probability. I give it the name of the model that I just built, and I give it the conditions that I want to use. So for example, I'm going to predict based on which married fans are likely to buy. So I say I'm using yes for married on marital status, and it'll return me the probability of that. Next, let's talk about real-time analytics. So Oracle makes it simple for apps to provide instant data insights. So we have in-memory columnar formats and automatic parallel processing that enable analytics to run transparently over 100 times faster. And no app changes are needed to achieve this. You can easily deploy these parallel columnar algorithms in either an OLTP database or a data warehouse database. All you have to do is call SQL, which makes real-time analytics super simple. Graph analytics are a very hot new area, and Oracle makes it simple for apps to use graph analytics to discover things like influencers, dependencies, communities, ranking, and customer 360. Again, we use declarative SQL-like queries to make development of graph analytics really simple, and we have over 50 in-memory parallel analytic graph functions built into the database. This graph analytics used to be a priced option, but now it's free in all database editions, and it makes graph analytics dramatically simpler to implement. We have over 50 algorithms. So we have algorithms for detecting components in communities, ranking and walking, link prediction, evaluating community structures, pathfinding, etc. And today we have hundreds of enterprise users of graph analytics. Here's a quick example of what this looks like. So we use an open source graph query language called PGQL, and it allows you to specify graph patterns which are matched against vertices and edges in a graph. And this is a quick example of how the SQL looks like. And we've introduced new syntax. For example, the parens are actually represent edges, and the brackets represent nodes. And in this example, I'm querying to find out the outgoing edges from Barack Obama. So you can see it's very simple SQL. Okay, document data. So documents are key today to modern programming. And Oracle makes it simple for apps to use JSON and XML documents in the database. And this really simplifies development because you're using the same JSON data format that you use in the application inside the database itself. Oracle allows you to freely mix JSON and relational data in the same database, and we provide dozens of powerful JSON capabilities inside the database. You can index any JSON element to make JSON very fast for OLTP. You can use parallel SQL to run analytics on JSON, as well as a combination of JSON and other formats. And Oracle provides full ACID capabilities on all the JSON inside the database. And this makes document data in the database dramatically simpler. Again, here's a very quick example of how easy it is to run JSON inside the database. So in this example, we're creating a menu items table where the menu items are stored in JSON. So we see a create table, we have a restaurant name, and we have menu items. So these are formatted in JSON. And a JSON looks just like JSON normally looks. So for example, in this menu item example, we're storing an ID, a name, and a price for the menu items. Although because it's JSON, these can vary based on the restaurant. So you might have specials, you might have desserts and appetizers. These can all be annotated in JSON. And we've extended SQL to make it super easy to query these JSON attributes. So you can use simple dot notation to access elements within the JSON document. So in this example, you can say select menu item dot name to get the name JSON item inside the JSON document. So it looks very native, it's very simple, and it's very easy to program. Next, let's talk about text search. Oracle makes it simple for apps to index, search, and analyze text documents. So you can use text search for either keyword search, context queries, pattern matching, etc. For example, you can search website content, catalogs, documents, or data inside logs in the database. And it's not just simple search. You can also perform linguistic analysis on documents to easily classify them. For example, you can classify customer feedback as either positive, negative, or neutral using the sentiment analysis that's built into the Oracle text search algorithms. You can also search for text inside JSON or XML documents using the structure of the document to restrict the search. For example, you can find all the purchase orders where a comment field contains damaged or delivery. By building text search directly in the database and letting it run with SQL, it makes text search dramatically simpler. So here's a quick example of how you use text search in the Oracle database to search inside a JSON document. So first of all, I create an index. In this case, I'm creating a search index, so I provide the key word search when I create the index. And I'm creating it on a JSON column So I put for JSON at the end. Super simple. Now to do the search, in this case, I'm searching for PO documents with delivered or damaged in the comments field. It's very just simple. I just put in the where clause. I'm looking for JSON text contains in the comment field delivered and damaged. That's all I have to do. And I've done a text search inside the Oracle database. Okay, spatial data. Oracle makes it super simple for apps to use and analyze locations and networks using declarative SQL inside the Oracle database. So using spatial capabilities of Oracle, you can compute the distance between places, assets, and people. You can do much more sophisticated things like analyze transportation networks, telecom networks, utility networks, and sales territories. Also, you can use it for plan data management, public safety, and defense. We have hundreds of in-database spatial operators and functions that we've built over decades using our spatial technology in the database. Again, previously, the spatial technology in the Oracle database was a priced option, but now we've made it free to use in all Oracle database editions. So it's super simple to use spatial data in the relational database. We have over 100 spatial network functions and over 60 spatial topology functions and procedures that are built into the Oracle database. And today, thousands of enterprises are using our spatial technology directly in the database. Here's a simple example of how you use spatial functions in the database. So in this case, I'm trying to find all the restaurants that are within 5 kilometers of my home. And again, it's a simple function that I call. I say SDO within distance, the 2 places I'm looking at the distance from, and I say I want distance equals 5, unit equals kilometers. That's all you have to do to find locations within 5 miles of my home. Super simple to use. Okay, blockchain. Blockchain is a very popular new data paradigm, and Oracle makes it very easy for apps to use these new blockchain technologies to help identify and prevent fraud. And the way this works is that in Database 20C, we have a new type of table called a blockchain table. And this looks a lot like a normal table, except as the rows are inserted into the blockchain table, they're cryptographically chained together, and this happens automatically. This chain, this cryptographic chain, can be verified and signed by the participants to detect any kind of fraud. Now, blockchain tables are very simple to integrate into applications because they look like standard database tables and you use the same declarative SQL against them. You can run full analytics and transactions on blockchain data, which no one else provides. Using these technologies, Oracle makes blockchain technology super simple to use inside the Oracle database. Here's a very simple example. When you create a table, all you have to do is put the blockchain keyword in the create table statement, and you get a blockchain table, and it does the cryptographic chaining automatically. And there's a number of benefits that you get. First of all, you just use normal SQL. So here's how I insert a row into that table. Looks like any other insert. One thing that happens with blockchain tables is we automatically prevent the users from updating or deleting rows in the blockchain table. But more importantly, we allow the blockchain table to be verified. So you can call a procedure that will verify the contents and make sure that no one has tampered with the table by validating the cryptographic blockchain. So super simple, looks like a normal table, transacts like a normal table, queries like a normal table, but get the benefits of the fraud detection of blockchain. Okay, let's talk about something else, Internet of Things. So Oracle makes it super simple to develop applications that stream Internet of Things data into the database. And the way this works, again, is using standard SQL. So use a standard SQL insert to stream IoT data. But for IoT data, what Oracle will do is quickly deposit the IoT data into in-memory buffers instead of inserting them directly into the database. And then we have a background process that bulk loads this IoT data into the database in background. What this means is you get ultra-fast IoT technology for inserts. So we can insert over 25 million elements of IoT data on a 2-socket server using this technology. And you can then analyze the IoT data using the time series analytics that's built into the Oracle database. So using these technologies, it makes it super simple to develop an IoT application on top of the Oracle database. Again, here's a very simple example of how you use IoT. When you create the table, you say it's mem optimized for write. That means we're optimizing for IoT writes. When you insert data, you tell us this insert is optimized for write. It's optimized for IoT streaming writes. And again, we do the memory buffering automatically. I've talked about how Oracle simplifies the new development paradigms and also how Oracle makes it simple to use the new sophisticated algorithms to create value from data. Now let me talk about how Oracle simplifies the overall data and application architecture by converging data. First of all, let's talk about what it means to be converged. So there's a difference between a converged product and fragmented features. So for example, phone calls, messaging, photos, etc., originally required you to use a separate product for each feature. Now all these have been converged into a smartphone. The smartphone does all these things. Similarly, machine learning, JSON, blockchain, etc., originally required you to use a separate database for each. Now we've converged these features into the Oracle Converged database. And a converged product is inherently simpler than running many single-purpose products. Not only is it simpler, it enables what we call cross-data synergy. So in the phone example, converging internet, videos, and photos enables new capabilities, such as, for example, revolutionary social networking, which was never possible before. Similarly, when you converge data, it enables new capabilities. So converging machine learning, documents, social, and location data can enable revolutionary new breakthroughs like in personalization or fraud detection. So converging data enables you to generate more value, and it's dramatically simpler. There's an ongoing debate about this converged versus fragmented architecture. For example, vendors like Amazon and niche database vendors promote using single-purpose proprietary databases for each data type and each workload. So you have a database for OLTP, another database for documents, another database for IoT, another database for time streams, another database for analytics, another database for blockchain, etc. Text search, it goes on. The Oracle strategy is that we run a single converged open Oracle database and put all the data types and workloads inside that database. Now, what are the advantages of this? It's obviously dramatically simpler for developers to just invoke declarative SQL when they want to run a machine learning algorithm, a graph search, internet things, insertions, to run a spatial query, to do blockchain inside one converged database, instead of having to implement multiple fragmented databases and then use distributed execution and data movement across them to accomplish the goals of the application. Obviously, dramatically simpler. It's also dramatically simpler on operations to operate one converged Oracle database instead of having to individually make each of the single-purpose databases highly available, secure, scalable, using product-specific mechanisms, and move data constantly between them, which are in different formats. One of the things that people worry about with a converged database is it doesn't seem as open. In fact, though, it's much more open. For example, when you look at Amazon databases, they only run on Amazon. Oracle database runs everywhere, on-premise, on Amazon, in the Oracle Cloud, in Azure. Furthermore, Oracle uses standard APIs, open standard APIs like SQL, Java, REST, and JSON. Other niche database vendors often use proprietary APIs that only work on their platform. In the case of Amazon, they start with these open source databases with proprietary interfaces, and then they close them and add further proprietary interfaces. So the Oracle Converged database is actually much more open than the alternatives. Even though they might be open source, they're not open API, which is even more important. We've talked about simplifying development paradigms. We've talked about simplifying how you create value from data using all these new sophisticated algorithms. We've talked about how to simplify the architecture using a converged database. Now, let's end by talking about how you simplify administration and operation and focus on value creation. So we're in a new era of database where everything is automated. Traditionally, mission-critical databases were quite complex and difficult to use. We now have Oracle Autonomous Database that makes data management super simple. So you can create an autonomous database with a few clicks in less than 5 minutes. An autonomous database eliminates all the management and maintenance. Autonomous database is available both in the public cloud, but it's also available in your data center using our cloud at customer technologies. And the benefit of this is that it frees both DBAs and developers to focus on some of the things I talked about earlier, innovating and creating new value. Makes data management and operations dramatically simpler. Now, this has a number of components. For example, performance became dramatically simpler. So Oracle has always been the most powerful and most mission-critical database, but now it's also the simplest to scale and to tune. So we provide in our autonomous database a transparent scale-out architecture. So you don't even have to know that it's going on. You just write your SQL, we transparently scale it out. We provide transparent SQL parallelization. So a single analytic SQL statement can be parallelized over hundreds of processors to run dramatically faster, and you don't have to do anything. This happens completely automatically. We provide transparent smart storage with persistent memory in our Exadata platform that runs Autonomous Database. We provide transparent columnar formats, in-memory columnar formats for accelerating analytics. We automatically index the data for OLTP based on the exact workload, and the indexing dynamically changes as the application changes. And we transparently create SQL statistics and optimization to keep your application tuned. So extreme performance, which used to require a lot of work, is now super simple with Oracle Autonomous Database. Let's talk about fault tolerance and how we've made that simple. So we provide fault tolerance and full ACID built in and fully automated in the Autonomous Database. So failures become completely transparent to the application. As an application writer, you don't have to worry about it. For example, server failures, storage failures, database crashes and failures, entire site failures, user errors, and online updates are completely transparent when you use an autonomous database. So as a developer, you just write your code. Oracle takes care of all the fault tolerance, making it dramatically simpler. Security is another source of complexity. So traditionally, keeping up with the constantly changing security requirements and updates is difficult and time-consuming. With Autonomous Database, Oracle owns securing the entire data tier. So we provide a highly secure configuration where all data is automatically encrypted and security updates are automatically applied completely online with no interruption to the application. So you don't even have to think about it. This gives developers a highly secure database in minutes. So you don't have to fight IT over security. It's there by default, super secure, super simple. Finally, sizing and scaling. So Autonomous Database uses a serverless architecture that automatically scales to match the changing workload. So we can instantaneously adjust the CPU and IO. So you can grow the CPU, shrink the CPU, grow the IO, shrink the IO dynamically without having a restart. There's no need to predict sizing ahead of time or constantly monitor to make sure the sizing is correct. And also, it can go all the way down to turning the database off when it's not in use. And a big benefit of this is that you size and pay for only the CPUs and storage that you actually use. So it dramatically lowers costs. So sizing and scaling are made dramatically simpler with Autonomous Database. And prototyping using Autonomous Database is super easy and simple in our always free cloud tier. So So in our public cloud, we provide you an autonomous database, compute, storage, networking, and many more services for free, always free. In the Autonomous Database, we've already built in and integrated our Application Express Apex low-code development, web-based application development, and SQL Developer. So when you get an Autonomous Database, it's all there. You just click and start building. So prototyping data-driven apps in the public cloud is dramatically simpler. All the management and operations is completely eliminated.
Independent industry analysts agree that Oracle's integrated, declarative, converged, and autonomous approach to developing data-driven applications is both simpler and delivers business value faster. For example, Carl Olofsson, Research Vice President of IDC, says that Oracle's integration of leading-edge developer technologies like machine learning, JSON, graph, events, low-code, blockchain, microservices, and CI/CD into a single converged database with autonomous management makes Oracle Database a comprehensive self-managing data platform for new projects and applications. And to achieve similar results using open source databases, developers must string together many products, resulting in a solution that is much more difficult to develop and maintain and poses data fragmentation issues. Olga Mueller, VP and Principal Analyst at Constellation Research, says that the ability to run all the critical enterprise database workloads, from analytical to transactional loads, in an autonomous fashion, as well as support for ML, graph, IoT, JSON, and more, sets the Oracle Autonomous Database apart in the market for databases. Would you rather have 9 specialized databases, each with its own separate security profile and management learning curve, or a single database that operates with all types of data sets autonomously?
Finally, I want to summarize the key takeaways from my talk today. First of all, Oracle makes it dramatically simpler to build data-driven apps. And I've talked about how we provide synergistic data paradigms for each development paradigm to simplify the data architecture and make it work synergistically with the application. Second, I've talked about how we provide native declarative SQL support for all the key data types and algorithms, things like machine learning, JSON, spatial, etc. Then I talked about how we use a single converged database for all different kinds of data. And this has 2 very important benefits. One is that it enables synergy across all the different kinds of data. And the second is that it makes it dramatically simpler to develop and operate the database. And finally, I talked about how Autonomous Database brings in a new era in database management that eliminates the administration and operations burden, enabling much faster and more effective development and innovation. Before finishing today, I want to make 2 exciting announcements that are particularly interesting for developers. First announcement is that we will be shipping a new autonomous JSON database. And this JSON database has the features of MongoDB and more for a much lower price. So the autonomous JSON database is a new cloud service built specifically for JSON-centric application development. It uses native JSON storage with advanced indexing. It provides transparent scale-out with full ACID transactions on all data. You access the JSON database using document APIs. These are JSON-centric APIs that you call from either the database drivers in the application, command line, or using REST. Applications can be built entirely without SQL, but you can use SQL for cross-collection queries, reporting, and analysis on JSON data. When you use a JSON database, you can, with a single click, add relational database capabilities to transform it into an autonomous transaction processing database that has both JSON and relational data in it. Why would you use autonomous JSON database? Because there are many reasons, but few are that it's very simple to develop. You can start in minutes with our developer-friendly APIs. It's very simple to operate, and it provides all the autonomous database capabilities, including super high availability. And it's dramatically lower cost. So we have a lower price than MongoDB, and we provide true pay per use, which lowers the price even more using our serverless architecture with no fixed shapes. So for the same amount of processing power, you get a lower price and many more capabilities than MongoDB Atlas provides. The second exciting announcement I want to make today is about Oracle Database on Kubernetes. So we've been working for a long time to dramatically simplify Oracle Database deployed in Kubernetes. And today I want to announce that Oracle Database 19c Docker images are now available. And also Kubernetes Helm charts for Oracle Database are now available. And we'll continue to work to make Oracle Database work fantastically on Kubernetes. Thanks for joining me today. Coming up next are more in-depth sessions on some of the topics that I talked about today.